Let's work through an application problem. So the hypotenuse of a right-angled triangle is 20 centimeters in length, and we want to calculate the measures of the unknown angles in the triangle that will help maximize the perimeter. Let's start by drawing a picture of what's going on here. So we have this right-angled triangle, and we know its hypotenuse is 20 centimeters. And we want to know the unknown angles. So I'll label one of them theta, and let's label these other sides A and B. Let's look at the relationship between these unknown sides and the angle theta. Because A is adjacent to the angle theta, I can write A as 20 cos theta. Similarly, B is opposite of angle theta, so B is equal to 20 sine theta. Now, because we're trying to maximize the perimeter, let's write an equation for the perimeter. So we have P is equal to 20 plus A plus B. But let's substitute in those equations that we just found for A and B. So we have the perimeter is equal to 20 plus 20 cos theta plus 20 sine theta. Next, I'm going to go ahead and factor out the 20 from the cos theta and the sine theta to get 20 plus 20 times cos theta plus sine theta. Now let's remember that we're trying to maximize the perimeter, and whenever we're trying to maximize or minimize something, we want to take the derivative with respect to the unknown. We'll take the derivative of P with respect to theta, and that will give us 0 plus 20 times negative sine theta plus cos theta. So let's go ahead and rearrange that. So we get the derivative of P with respect to theta is equal to 20 times cos theta minus sine theta. Now, because we're trying to maximize or minimize, we want to find that turning point, so we're going to set the derivative equal to 0. So it's going to give us 0 equals 20 times cos theta minus sine theta, which is going to give us 0 equals cos theta minus sine theta, which then gives us sine theta equals cos theta. I'll divide both sides by cos theta, so I get sine theta over cos theta is equal to 1. Now, remembering our trig identities, sine over cos is equal to tan, so I get tan theta is equal to 1. And I then take the inverse tan of both sides to get theta is equal to pi over 4, or 45 degrees. So then the angle that's going to maximize the perimeter would be if theta was pi over 4, or 45 degrees, which in turn means that the other angle is also pi over 4, or 45 degrees.